Hello, and welcome to Principles of Microeconomics. This is Module 5.4, and we will be discussing oligopoly. Oligopoly is a type of market structure that has slightly more competition than a monopoly, but slightly less competition than perfect competition. So what we see in a monopoly market structure is that we have a few number of firms, sometimes two, sometimes three, and they are selling an identical good. What we observe is that for the firms to try to reach the optimal point of production, they must work strategically together and cooperate or collude to reach the monopoly outcome. But because each of the firms is faced with a tension between cooperation and acting in their own self-interest, what we see is that many times the cooperation breaks down and the firms end up cheating and reaching a point of a suboptimal production point that is below the monopoly outcome. What we see in oligopoly is that the best outcome is for our firms to cooperate. They can produce a small quantity of output where the price is greater than the marginal cost, and it is giving them the highest possible profits. But as I have mentioned, it is also in their self-interest to try to cheat. So, to reach the monopoly outcome, they each have to rely on the other firm that is also operating in this market, and they have to trust that the other firm will not cheat. So let's look at an example here to understand oligopoly in a little bit greater detail. So let's assume that we have two firms, one owned by Jack and one owned by Jill. And they own the only water that is available in town. So Jack and Jill are both responsible for bringing water into town and selling it. For the point of simplicity, let's assume that marginal cost is equal to 0. So therefore, our total revenue is going to be equal to total profits. So as we observe on this table here, you can see the quantity of water that they bring into town, quantity that they produce, and the price of water that they can set. So if we look at this table, our total revenue will be equal to our total profits, again, for the point that we are assuming marginal cost is equal to 0. So the highest possible revenue, highest possible profit, is going to be at a point where they produce 60 units of water and they charge $60 per unit. Their total revenue is going to be $3,600. So they're going to split this evenly so that Jack is going to produce a quantity of 30 units of water and Jill is going to produce a quantity of 30 units of water, each of them charging a price of $60. Now, if they cooperate, they can reach the monopoly outcome. The price is 60, the total quantity of water is 60 gallons, and the total profit that they can make is $3,600. Jack's profits, therefore, will be $1,800, price times quantity, and Jill's profits will be $1,800. But now, what happens if one of them cheats? Let's say that one of them cheats and they produce 10 more gallons. So if they produce 10 more gallons, the quantity rises to 70 gallons of water entering the market. According to our previous table, at 70 gallons entering this market, the price is going to be $50. So the price falls and the total quantity rises. Our profits fall to $3,500. So for the cheater, this is beneficial to them because now their profits have risen from $1,800 to $2,000. Now, for the person that has chosen to cooperate, they're still producing the 30 gallons that was agreed upon, but now they're facing a lower price of $50. So their profits have fallen. So this is going to be bad for the person that chooses to cooperate. Now, since there's only two firms in this market, they both know exactly what this table looks like. And they both know exactly what can happen if one of them cheats. So therefore, they are faced with trying to reach the monopoly outcome of $1,800 each, or knowing that if the other person cheats, they're going to be faced with lower profits of $1,500. So what do? The oligopoly outcome is going to tell us that both agents are going to cheat. Because what happens if they both produce more? Jack produces an extra 10 gallons and Jill produces an extra 10 gallons. That tells us that the total quantity of water entering into the market is going to be 80 gallons. The price then falls to $40. So for Jack, his profits will be $1,600, and Jill's profits will also be $1,600. The oligopoly outcome tells us that they both cheat because they're both acting in their own self-interest. The benefit is that if they cheat and the other person cooperates, they get even higher profits than the monopoly outcome. And the risk, if they cooperate and the other person cheats, is that they have much lower profits than they otherwise would. So we can see that the interest of cooperation fails, and they both end up cheating. Now, this idea of the oligopoly outcome pairs well with game theory, because game theory tells us that each agent is going to be basing their decisions on the strategic outcomes of what could possibly be happening based on the other decisions of what other players are doing. The Nash equilibrium is going to tell us that agents that interact with one another will choose their optimal strategies given the strategies that all other agents have chosen. So one firm's optimal strategy is going to take into account all of the possible other outcomes that can occur based on the other decisions that the other firms can make. So the Nash equilibrium is going to tell us that both of them are going to cheat. The oligopoly outcome is going to tell us that it can be calculated as n divided by n plus 1, where n is the total number of firms in the market multiplied by the competitive outcome. Now, the competitive outcome, if we look back on the table, is going to be at the point where our marginal revenue is equal to our marginal cost. And that's going to be a point where we're producing 90 units at a price of 30. So what we're going to see is that as the number of firms increases, we get closer to the competitive outcome. Because it becomes more and more difficult for the firms that are in the oligopoly market to cooperate. So there's going to be more and more incentive to cheat. Now, if we think about this in the context of game theory, let's think about Jack's choices. Jack's choice is either to cheat or to cooperate. And Jill's choice is also either to cheat or to cooperate. Now, if they both cooperate, the possibility is that they both make profits of $1,800. Now, if Jill cheats but Jack cooperates, this is going to be beneficial for Jill because she makes even more profits, and it's going to be costly for Jack. Now, if Jack cheats and Jill cooperates, this is going to be very beneficial for Jack because he makes $2,000 rather than $1,800. So, given this information, knowing that they would both lose significantly if they cooperate and the other person cheats, and knowing that the other person might be able to make a lot of profits if they cheat and not cooperate, the best thing for them to do will be to both cheat. So this is going to be the oligopoly outcome and our Nash equilibrium. What this tells us is that regardless of what the other person does, it is best for Jack to cheat and it is best for Jill to cheat. And this will be the oligopoly outcome. Both of them will fail to cooperate and they will cheat to act in their own self-interest. Thanks so much for joining me in Module 5.4 on oligopoly.